identify types of particles also, at least in some living cases. So let me show you a few pictures to set the scale. I'll show you first this thing shown in green. It's called the electromagnetic calorimeter. This is the thing which the Nevis group worked mostly on. So here's some pictures. It's a cryogenic detector, which means it sits inside a big refrigerator. That's this big refrigerator here. Here you see the detector being installed inside that refrigerator when the cover was removed. And in fact, inside the inner part, which you can see going in here, goes a superconducting magnet to bend charged particles that allow us to measure the momentum. So we put all this together at CERN. We closed up the can. We put a little hat on it because it was raining in Geneva that day. And then we drove it exceedingly carefully across the street. And then we hung it on cables, so we trusted our engineering friends with their calculation of the strength of these cables. This is about a $100 million piece of equipment. And what you see is you're looking down from the surface, down 100 yards to the ATLAS cavern below. Okay, so we're lowering it. Here you see it emerging from the shaft that we used to lower the pieces, and finally coming to a temporary resting place at the end of the cavern. Okay. So when it was all done, it looked like this, and so I should mention for local, what Columbia did here was we designed and built all the electronics which goes in all these gold boxes. And so you can see myself and some Columbia colleagues here installing, in fact, the very first electronics board that we installed back when we were building this detector. The thing which dominates this picture probably are these big racetrack looking things. These are some of the world's largest superconducting magnets. There are 8 of them in the central region that we call the barrel. So these are toroidal magnets, so we call it the barrel toroid. I'll show you a picture in a minute. There are also, in the 2 ends, there are also large magnet systems we call the end cap toroids. So here are pictures to show you the scale. So here's one of the 8 barrel toroid modules. Again, being driven, so this was the first one that was going to be lowered down the cavern. So it was a pretty big event. The police came, they had to block off the street. We had to drive this thing across the street. It's 26 meters in length. Some poor guy was so distracted by all this that he drove his Mercedes-Benz into the side of the bus. So we said we'd seen our first collision. These were not the ones we designed for, I'm afraid. So that's the barrel toroid, and then you see one of the 2 end cap toroids before they kicked out the physicists so that they could put it inside the cryostat. So you see the scale, these are some of the largest magnets in the world. So when you put those barrel toroids together, this is what you get, and then back here the shiny thing with the gold boxes, that's a calorimeter that I showed you before. You see this is the next scale out. Finally, these big things on the ends, these are what we call muon chambers. So a muon, remember the heavy cousin of an electron, will pass all the way through all this stuff and go out into the dirt, and we'll go through these detectors so we can identify them that way and use the magnets to bend them so we can measure the momentum. So you can see a picture here of these chambers. This is a person. Okay, or another view. So very large structures. So what we can do is we can take a look, as you saw, we lowered individual pieces, we built the pieces on the surface around the world and assembled them at CERN, and then we lowered the individual pieces into the cavern through those 2 shafts, and then over the course of 5 years we had to build the ship in the bottle, put all that together. So we had some webcams set up for that while we were doing that, so we could see 5 minutes of assembly in the cavern in 1 minute. So you'll see some of the pieces that you'll recognize. So first the big magnet, here's the first magnet coming down. The calorimeter is about to appear. It stays at one end to stay out of the way while we lower the other magnets down so we can get it into its final position. We have to finish this wheel of 8. So that was a major activity for some extended period of time. Then when it's done, we put a calorimeter inside and build another calorimeter that goes behind it in the end cap and put it inside and then take it out, put it back in. Now you see it building these muon chamber walls, these huge assemblies. This is inner detector silicon-based tracking. Soon you'll see one of the big magnets, there's one big magnet coming down at the end. The other one coming in. Finally, the 5 years was done. say that I was in real time, and that's why we're called high energy physicists. So just a few factoids to take away about ATLAS. So as I said, it weighs about 7,000 tons. We're on the border with France, so our French colleagues tell us that's about the same as the weight of the Eiffel Tower.